All right, so we're talking about section 8.4, CPM and Pert. And so CPM stands for Critical Path Method, and it's used for project management. Same thing for Pert. Pert is also listed down here. It's the Program Evaluation and Review Technique. Um, so the Pert technique would be used to estimate probabilities. Right, so we're not going to do any statistics in this class, so we'll be skipping that part, but we will be talking about a critical path method. Okay, now to understand kind of what's happening here, let's take a look at table 12, and you can see um, this is the widget co problem. And in the widget co problem, we're about to introduce a new product. And so you can see that there are some activities involved in constructing this widget that's popular in business. And so we have these columns: activity, predecessors, and duration. And so, for example, the first activity is activity A, which will be to train workers. And that's the first kind of a first thing to do. So there's no predecessor activity to that. And so that takes a duration of 6 days. And similarly, activity B is to purchase raw materials. It has no predecessors. So and it takes a duration of 9 days, and so on. So you can see what's happening here. The next one, C, is to purchase product 1. And before you purchase product 1, of course, you should train your workers and also purchase your raw materials. And so those are predecessors to activity C. So that means that A and B must be complete before we do activity C. And that activity C takes 8 hours. And similarly, activity D has 2 predecessors, A and B again, and so on. So activity E, activity D must be complete before activity E can start. And activity E is it's supposed to be 10 hours in length, or 10 days in length. Good. And then finally, the last activity depends on C and E being complete, and it takes 12 days or 12 units of time. Okay, so somehow we want to arrange these letters, these activities, into a network. Okay, and so this page is the last page I'm going to do. I'm not just going to read the book to you, but I did want to show you something, and that is this network right here. This is kind of a weird network. So what this is doing is it's taking the activity. It's called activity on arc, or activity on arrow, which is abbreviated as AOA. And so the nodes aren't activities. Those are just kind of resting places. And so activity A, we're saying, occurs on the edge between 1 and 3. And then activity C occurs on the edge between 3 and 5. I think that is, yeah. And so this is kind of an awkward way to write this. People use activity on arc when they're going to do PERT. But since we're not doing PERT, we're doing CPM, that is, we're just doing the critical path method, then we're going to do activity on node. So let me pause for a second and get the paper out, and I'll actually start writing some stuff. Good, so I'm back. And I want to think about what would I write if I want activity A followed by activity B followed by activity C. If we're doing activity on arc, like we were just doing in the looking at the book, then we would write node 1, right, and then node 2, and then node 3, and then we would need one more node, right, and then we would put A here, B here, and C there. Excuse me. So we're not going to do that. I'm just doing this as a point of comparison because we're going to do something that's not in the book. And that is, we're going to take activity A, and then we're going to follow that by activity B, and then we're going to follow that by activity C. And I think you'll agree, right, that this is the more natural way to do this. Okay, so now let's look at some more possibilities here. One moment, please. Okay, so in this example, I'm looking at these columns, right? And I see activity C, and then I see that the predecessors were A and B. And so this would mean that A and B must be completed before activity C, right? So how would you draw the diagram for that? Well, we would have activity A, activity B, whoops, and then activity C. Okay, so this would be that activity A and B must be completed before C. Good. Similarly, what would this look like if you had like an A with nothing and then a B, A, C, A? Okay, in this case, we're saying that activity A must be complete before B and activity A must be complete before C. And so therefore, it's kind of the reverse of that. Activity A has to come first, then you can do B, then you can do C. Good. Now, let's try another one. What would this one look like? A, B, C, then A, B, D, A, B. Okay, so by the way to read that is that nothing has to be done before A, nothing has to be done before B, but A and B have to be completed before project C, and then A and B have to be completed before activity D. Did I say project C? I meant activity C. So how would you draw the diagram for that? Okay, you would take A and B and C and D. And so A has to be finished before C, B has to be finished before C, right? And then similarly, A has to be finished before D, and B has to be finished before D. Good. And so that's how you would draw that. Good. So this is actually a lot easier than doing the activity on arc, because in the activity in arcs, you have to use dummy edges and things. Okay, I think I've complained enough about activity on arc. Okay, so let's maybe before we finish this page, let's go ahead and expand our understanding. Maybe I'll use this from the book. And let's see, I'm going to do this the old-fashioned way. So this is the table from the book. So you see A doesn't have a predecessor, B doesn't have a predecessor, C has A and B, D has A and B, by the way, we just worked with that, right? And then E has predecessor D, and then F has predecessor C and E. So you should pause the video and see if you can draw the network diagram for this picture. And I will try to draw it underneath here. Okay, are you finished with your guess? Then let's see how we do. So we have A and B doesn't have anything to predecess them. By the way, some people like to put a start button here or a start node here, and that does make sense. So let's go ahead and put a start, and then we'll run A and B, and then C and D both depended on A and B being finished. That was something we just looked at. So we could write our C and our D, and so A has to be there, B has to be there, we have to have that arc, and we have to have that arc. Good. So that takes care of our first four. And the durations we'll work with in just a second. Let's see. E comes after D. Good. And then F depends on both C and E being completed. And there's our diagram. So again, some people might put an end button right there. Good. So this is the diagram that we get, right? And if you flip this, if I flip this over to this page, you can kind of see what the book has as a point of comparison. They have to have a dummy edge in here, and yeah, okay. They do have a start node and an end node, which is what we have also. Okay, but I do think, like I've said numerous times already, I'll stop saying it. I think this is a lot more natural. Okay, so what are we going to do next? Next, we're going to evaluate a few numbers on the network. And so the way we're going to do that is we're going to put a little diagram or a little chart of 6 numbers on each activity node. And so the placeholders are for activity, duration, and then something called ES for early start, and EF for early finish, and then LS for late start, and LF for late finish. Okay, and we'll define what those numbers are in just a moment. I think we're running out of time. But just to give you an idea of how we're starting this, like for node A, we're going to put A, and then we'll have our 6 underneath there. And then we'll put B with our 9, C with 8, and so on. I'll let you finish that off too. D goes with 7. F, whoops, I put an extra one there. Oh, I'm in too big of a hurry. F has 12. And then E, I'm just about done. E10. Okay. We'll come back and we'll try to finish this by defining and computing these 4 numbers. See you then.